Hey everyone! Welcome back to my YouTube channel. Today we're breaking down a really important concept in statistics: confidence intervals. Whether you're a student, a data nerd, or just curious about how polls and surveys work, this concept is essential for making sense of real-world data. So, what exactly is a confidence interval? In simple terms, it's a range of values we use to estimate something we don't know, like the average age, height, or opinion of an entire population. We don't usually have data for the whole population, so we take a sample mean or proportion, and we try to make an educated guess about the population parameter using that. This guess is called a confidence interval, and it's a type of probability statistic. Now, at the center of every confidence interval is a point estimate. That's a single value like a sample mean or percentage that we use as our best guess to the corresponding population parameter. Let's say we survey a sample of 1,000 voters in Guyana, and the average age turns out to be 53.7 years. That number 53.7 is our point estimate for the true average age of all Guyanese voters. But one number doesn't give us the full picture. It's precise, yes, but not necessarily accurate. So, we use a range instead. That's where confidence intervals come in. A confidence interval creates a range of values where we believe the true population value likely falls. And how wide or narrow that range is depends on the margin of error. The margin of error is like our wiggle room. It depends on how spread out the data is, standard deviation, and how big your sample is. A larger sample usually gives you a smaller margin of error, which means a more precise interval. Then there's something called the confidence level, usually 95% or 99%. A 95% confidence level means if we repeated this survey 100 times, about 95 of those intervals would contain the true population value. So, it's not a guarantee, but it tells us how confident we are in our estimate. To calculate confidence intervals properly, we make a few key assumptions. The sample must be random. The data should follow a normal distribution. And we consider whether the population of the standard deviation is known or unknown. When the population standard deviation is known, we use Z and nominal distribution to determine the critical value. However, we use the T and the T distribution when the standard deviation is unknown. Let's walk through another example. A sample of 100 university students shows they study 15.3 hours per week on average, with a standard deviation of 4.2 hours. What's the 95% confidence interval? We're given the sample mean 15.3, the sample standard deviation of 4.2, and the sample size of 100, and a 95% confidence level, which has a ZES score of 1.96. Using the confidence interval formula, we plug in the values, so 15.3 plus and minus 1.96 multiply by 4.2 divided by the square root of 100. This sums up to 15.3 plus and minus 0.8232, which is our margin of error. With this, we get 14.4768 and 16.1232, our intervals. We can now conclude that 95% of our true population mean falls between the interval 14.4768 and 16.1232. Let's try an example using the t-value to construct a confidence interval. A sample of 25 light bulbs has a mean life of 1,200 hours and a sample standard deviation of 100 hours. Construct a 99% confidence interval. We are given the sample mean 1,200 with sample standard deviation of 100, the sample size of 25, and a 99% confidence level, which has a t-value of 2.797. We calculated the t-value using degrees of freedom and the t-table, which we have discussed in a previous video, so check that out. Using the confidence interval formula for a t-value and distribution, we plug in the values. So 1,200 plus and minus 2.797 multiply by 100 divided by the square root of 25. This sums up to 1,200 plus and minus 55.94, which is our margin of error. With this, we get 1144.6 and 1255.94 are intervals. We can now conclude that 99% of the true average lifespan of all light bulbs falls between the interval 1144.6 and 1255.94 hours. Now that you understand what confidence intervals are, how to interpret and calculate them, passing your next test should be a breeze. I hope you found this video helpful. Give it a thumbs up and subscribe for more explainer videos. And let me know in the comments if you want to see confidence intervals for proportions